So hello everyone. Today I'm going to tell you about Tinkercad and how to run Tinkercad and do basic things on Tinkercad. So basically Tinkercad is an online free app that helps you simulate your circuit or helps you make 3D diagrams or 3D objects. Whenever you need to test any circuit, you can test it on Tinkercad. Whenever you need to program anything on an Arduino or test an Arduino circuit, you can do it on Tinkercad. So I'll tell you how to log in on Tinkercad. So this is the Tinkercad website. If you go here and sign up or log in and sign up, you'll have various Tinkercad applications. That is, you can 3D design, you can create your circuits, code blocks, and so on. Tinkercad is a autotext website and it is very easy to use and it's user friendly. So once you log in into Tinkercad, in order to create or design any circuits, you need to select the options that are given here. So now we will be designing some basic circuits. You need to click on circuits, start tinkering, and create a new workspace for designing your circuits. Once you come to the screen, here this is the part where you'll be mounting all the components and creating your circuit and simulating it. On the right side here, we have all the basic components that are needed to simulate any basic circuit. From microcontrollers to resistors to capacitors, we have all the components available in the Tinkercad library. There are also wires, different types of wires that are available here, and also you can select the color of the wire depending upon your choice in the circuit. So now we will see different kinds of basic different kinds of circuits that are available in Tinkercad. Let's simulate those circuits. Here we have a LED light up. In order to make any circuit work, you need to click on the option Start Simulation. Once you start the simulation, here the LED is blinking. Similarly, we can see LED dimmer. So this is a circuit which fades or it controls the intensity of an LED using a potentiometer. So when you start it, this is the way you can dim or brighten the LED using a potentiometer. Similarly, we have various inbuilt multiple circuits in this. For example, DC motor using a photoresistor. So here as we change the value of the photoresistor, the value of the DC motor changes, that it moves faster or slower depending upon the value of the photoresistor. Similarly, we have various inbuilt circuits here in Tinkercad that you can try and simulate first. And in order to delete anything or you want to deselect a component, you just need to select the component and press the delete button, and your particular code or particular component gets deleted in Tinkercad. So this is how we basically use Tinkercad. And if now we should learn more about how to code microcontroller and how to create basic circuit and simulate using Arduino. Now we will try on some circuits using microcontroller Arduino. So in order to select the Arduino board, you need to search your Arduino Uno, select the board and place it on the screen. Now you can select any components and a wire will get automatically selected and place or make your circuit. Here, since we are using a microcontroller, we need to code the microcontroller. We need to give certain commands to the microcontroller in order to make our circuit work. So in Tinkercad, we have various options, like we can uh, make the code in block format or we can write the code in text format too. Here we can write the code in text format. Let us see working of some simple programs or simple circuits using Arduino Uno.
Today we're going to learn basic Arduino programming on Tinkercad. This is a basic LED circuit. Here the one terminal of the LED is connected to the ground, whereas the other terminal is connected to pin number 8. That's the reason we have mentioned integer LED pin 8. Then here LED is our output. That's why in void setup we have mentioned it as output. In void loop, we put digital write LED pin high. That's when the LED glows high, and after a delay of 1000, which is 1 second, the LED glows low. That is, the LED turns off. This is the basic working of this code.
Just like we blinked a single LED using Arduino Uno, we can blink multiple LEDs in a different manner using Arduino Uno. And here is an example of how to blink multiple LED. This is the code that you can use to blink multiple LEDs using Arduino Uno and Tinkercad.
So this is the code to blink RGB LED. The green pin is connected to pin number 13, hence we have mentioned LED G13. The red pin is connected to pin number 11, hence here it's mentioned LED R11. And the blue is connected to 12 and so on. Here in pin mode, we've set all the LEDs as output. And in void loop, 0 to 255 means random 0 to 255 means random connections of R, G and B, which is high. So it gives different combinations of RGB colors. And this is the code for lighting the LEDs in an array. We have used an LED array of 8 by 8 where the row numbers are mentioned, and these are the pins for the LED columns. In order to glow an LED in a certain manner, here we've mentioned the type of the array in which we need the LEDs to glow on. Here 1 means the LED is high and 0 means the LED is low, but this can be changed using the side switch that is put on pin number 13, which we have mentioned in the setup. So when we turn the side switch on, the combination of LEDs on and off inverts, and the ones which are off they turn on, and vice versa. And in void loop we have mentioned the code to turn the LEDs on and off.
This is a circuit diagram and the code where when we change the value of the potentiometer, the LED fades or glows brighter. That is, we can change the brightness of the LED using the potentiometer. Here the LED is connected to pin number 10 and hence we have defined here as pin number 10. The potentiometer knob is connected to pin A0. Here we've mentioned knob as 0. In void setup we mentioned pin mode as LED as output. In void loop we've mentioned a function analog read which will read the value of the knob, and here in the string we've mentioned sensor value. So we can also see that in the serial monitor what sensor value is getting printed. Whenever we increase the value of the potentiometer, the LED also glows higher and higher. And we can also see this on the serial monitor getting printed. Currently the sensor value is 5, but as we increase the potentiometer value, the sensor value also increases.
So this is a simple circuit of lighting an LED with the help of a push button. The pin number for LED is D13. Hence we have mentioned integer LED 13. The pin number for push button is D2. Hence we have mentioned integer push button 2. In void setup, we have mentioned push button as the input and LED as the output. In void loop, we have given the command digital read push button, which says that if the push button is on, the LED will glow high. That is, the LED will
glow. And if the push button is off, LED will turn low. That is, the LED will turn off.
This is a circuit diagram where you can hear the tone melody. This is an electronic component called as piezo. It has two terminals. One is connected to the ground and the other is connected to the 8th pin of the Arduino. We've created an integer int melody where we have notes like C4, G3, A3, and the notes are already defined here. In the void setup, we have given pauses in between the tones so that all the tones or all the notes can be heard distinguishedly. And if you need to repeat the melody, you need to add it in the code in void loop. Since here we are not repeating any kind of melody, we've only mentioned it once in the setup. So here is how you can hear the melody.
So this is the code to run servo motor. First of all, we need to include the library servo.h to run servo motor on Arduino. Then we have made the connections of servo motor. We have connected it to VCC, that is 5 volt, and ground. And output is connected to pin D9, hence we have mentioned pin 9.
In void loop, the servo motor sweeps from 0 to 180 degree in steps of 1 degree, and this for loop is for that. And the servo motor, after sweeping from 0 to 180 degree, comes back to its position
At a delay of 15 milliseconds.
So this is controlling the speed of a DC motor using temperature sensor. The motor pin is 5 and hence it is mentioned here in void setup, which is motor pin 5 and its output.
Temperature sensor is connected to pin A0 and hence we have defined temperature A0. If the temperature is less than 35, then the value 0 is returned, and
If the temperature is greater than 40 degree, then value 255 is returned,
on
which
the serial
means
monitor.
on the serial monitor, which means that if the temperature is less than 35 degrees Celsius, the motor stops working. But if the temperature is greater than 40 degree, then the motor starts working again. Here you can see the motor is not working right now, but as we increase the temperature above 40, it starts working, and we get 255 on the serial monitor. Whereas if the temperature is decreased below 30 degree, we get 0 on the serial monitor.
This is a simple circuit of photodiode. Here we have mentioned LED pin as the 13th, hence it's initialized as an integer LED pin 13. And button E pin is connected to pin D2, hence we have mentioned integer button E pin 2. In void setup, we have stated LED pin as our output and button E pin as our input. In void loop, we have given a if-else statement where we have given the command digital read. That is, if a button E pin is low, the LED will turn on, and if a button E pin is high, the LED will turn low. That is, the LED will turn off. So as you can see, as we move the slider, the LED turns on, and the other ways also, when we move the slider this way, the LED turns off. So this is a circuit of PIR motion sensor. PIR sensors allow you to sense motion, almost always used to detect whether a human has moved in or out of the sensor's range. So as you can see, this is the sensor which has three terminals. The signal terminal is connected to pin D2, hence we have given pin number 2 as our input. The second one is the power supply, which we have connected to 5 volt power supply, and the third one is the ground wire, which we have connected to pin ground. We have given LED as our output. In void loop, we are reading the sensor data. We have given a if statement which states that if the sensor pin is high, the LED will turn on, and at the same time Sensor activated. This message will be printed on the serial monitor over here. As you can see, it's getting printed. Otherwise, if the sensor pin is low, the LED will turn low. We have also given delay of 10 milliseconds. So we'll check the working of the circuit. This is a motion sensor. As you can see, as long as the object is in the range of a sensor, the LED is turned on. The moment it steps out of the range, the LED turns off. As you can see, the LED is off right now. The moment we get the object in the range, the LED turns on again.
This is a circuit diagram that tells us the proximity of the gases near to the gas sensor. If the gases are away from the gas sensor, you can see the green light glowing on. And similarly, as the gases come closer to the gas sensor, the yellow, orange, and red light glow respectively. The gas sensor is connected to A1 pin of the Arduino board, and that is why it is mentioned A1 here. Similarly, the green, yellow, orange, and red LEDs are connected to pin number 7, 6, 5, and 4. In void setup, we've mentioned all the LEDs as output. In void loop, the code is written in such a way that as the gas sensor senses the gases and the gases come at a certain distance, the LEDs glow. So here is how this circuit works. If the gas is away, it turns the green light on. As it comes closer, the yellow light turns on, and then the orange, and then the red. This is a circuit that will display the temperature detected by the temperature sensor on the 16:2 LCD screen. Here we have mentioned the file or the library include liquid-crystal.h. In order to display any message on a LCD screen on an Arduino, we need to include this file liquid-crystal.h. The pin numbers of the LCD that are connected to the Arduino are mentioned here, and here we've mentioned it too. In void loop, we've mentioned the temperature sensor as the input. In void loop, we have calculated mathematically and converted the temperature detected by the temperature sensor to print on the LCD screen in degrees Celsius. So here is how the working of the circuit is. When you change the temperature on the temperature sensor, the readings of the temperature on the LCD screen also changes.
So this is a circuit of our sensor. As you can see, this is a sensor and this is a remote. There are three terminals of the sensor. First one is connected to pin number 10 of Arduino board. Second one is the ground connection. And third is the power supply. As you can see in the code, we have included a library iremo.h, which we need to compulsorily include in the code for the functioning of the code. In void setup, we have given this statement enabling IRN, which will get printed on the serial monitor once we start the stimulation. It will be an indication that our receiver is going to start working now. Enabled IRN will indicate that the receiver is in working condition now, that it has already started working. This is in void loop. We have mentioned the code for the IR sensor. Right now we have given a default number which will get printed when any of the button is pressed on the remote. We can advance this code further by giving data which is more convenient according to our code, but right now, just to check whether our circuit is working or not, we have just given a random number. So we'll try checking the stimulation. We'll start the stimulation. As you can see, these two sentences have been printed. That means our our receiver is working right now. So I'll try pressing any random number. I press 2 and you can see the number has been printed. That means our circuit is working.
We have interfaced a 4x4 keypad with Arduino in this circuit. The number of rows and the number of columns of the keypad are mentioned here, and also we've mentioned the array of the keypad. The way all the letters in the alphabets are arranged, we've mentioned it in the array char key map. In void setup, we've just set the baud as 9600. And in the void loop, we have created a character key pressed. If the key is pressed, then key is stored in key press variable. And if the key is not equal to no key, then this key is printed out. And if the count is 17, then the count is reset back to 0. This means that no key is pressed during the whole scanning process. So here is how is the working of this circuit. When you initialize it and you open the serial monitor, once you press all the keys, they'll be displayed on the serial monitor, even the alphabets. So this is the basic working of this code.